I'm back. Second application has to do with finding the equation of a tangent and a normal to a curve at a point. Draw. Okay, here's a curve. Here's a point on that curve. Let's say the coordinates of that point are x1, y1. Here is a tangent to the curve at that point, a line that just touches the curve at that point. A normal would be a line that's perpendicular to the tangent passing through the same point. That's the definition of the normal. So this line here is the tangent, and this line here is the normal. The question becomes, well, how do you find the equation of the tangent and the equation of the normal at that point? Well, we should have the necessary tools in our background at this point. You would remember the main points we discussed when we were discussing the gradient, when we were discussing dy dx as a gradient function. When you consider dy dx to be a gradient function, you use it to find the gradient of a curve at any point. Gradient function can be used to find the gradient of a curve at any point along the curve. What was also true was that the gradient of a curve at a point is the same as the gradient of the tangent to the curve at that point. Right? So when you find dy dx, gradient function dy dx, if you plug a value of x into that gradient function, then you get the gradient of the curve and also the gradient of the tangent. Let me let m subscript t represent the gradient of the tangent. If you plug a specific value of x into the gradient function, you get the gradient of the curve as well as the gradient of the tangent. By definition, the normal is a line that's perpendicular to the tangent. And therefore, if I wanted the gradient of the normal, everybody knows for two lines that are perpendicular, the product of their gradients must be -1. So if m sub n represents the gradient of the normal, then that would mean that m sub n is equal to -1 upon m sub t. We learned that from our basic coordinate geometry. When did we do that? I think when we were doing the circle. And the two basic pieces of information that you need to find the equation of any line is you need a point through which the line passes, and you need the gradient of that line. If you know those two things, you can find the equation of the line. What we can do at this point is invoke the point-slope form for the equation of a line. Which is y minus y1 is equal to m into x minus x1. Then for the tangent, we simply plug in the coordinates of the point, x1, y1 would remain x1, y1. And the gradient of the tangent, we called it m sub t. Therefore, the tangent would have equation y minus y1 is equal to m sub t, whatever that value is, into x minus x1. For the equation of the normal, that will be written as y minus y1. The normal also passes through the same point. Y minus y1 is equal to m sub n into x minus x1. This is the equation of the tangent, the normal. All right. That's the theory. Let's jump right in and try to solve a problem or two. Find the equation of the tangent. Let me write it down. Find example number 1. Find the equation of the tangent and normal to the curve y is equal to, pick a nice one. Make up a nice one. Y is equal to 6 minus 3x minus 4x squared minus x cubed. Find the equation of the tangent and the normal to this curve. At the point where x is equal to 2. Make x equal to 2. Okay. So let's look at the sequence of things that we have to go through. First, we're going to find the gradient function, dy dx, which gives me, in this case, differentiating the constant, you get 0. Differentiating the minus 3x, you get minus 3. Differentiating the minus 4x squared, you get minus 8x. By now, you should be pretty sharp at this. And differentiating the minus x cubed, you get minus 3x squared. That looks good, I think. Minus 3 minus 8x and minus 3x squared. Okay. This is still my gradient function. And they're asking me for the equation of the tangent and the normal to the curve at the point where x is equal to 2. Okay. We know at this point that if we plug a value of x into the gradient function, that will give us the gradient of the tangent to the curve at that point. So when x is equal to 2, dy dx minus 3, a big number, minus 8 times 2, and then minus 3 times 2 squared. Mercy. Dy dx is equal to, I can't add. That's minus 12, minus 16, 28, minus 28, minus 31, I think. Can double check my arithmetic there. I think all right. Let's check again. Minus 16, 2 2's 4, 3's 12, minus 12, 16, 26, 28, 29, 30, 31. I'm pretty sure. Okay, that number is the gradient of the curve, but it's also the gradient of the tangent, which I'm going to call m sub t minus 31. I can automatically find the gradient of the normal. M sub n is minus 1 upon m sub t. M sub n is therefore minus 1 upon minus 31. Gradient of the normal is equal to 1 over 31. So at this point, I have the gradient of the tangent, I have the gradient of the normal. I need both coordinates of the point that I'm working with. Here, if you notice, I only have the x coordinate of the point, but that should not be a problem because if I plug back into the original equation, if I plug that x coordinate back into the original equation, I will get the corresponding y coordinate. So let's try that right now. Squeeze out a little space here. When x is equal to 2, y should be equal to 6 minus 3 times 2 minus 4 times 2 minus 2 cubed. Oops, that's 4 times 2 squared, it looks like. Minus 3 times 2 minus 4 times 2 squared and minus 2 cubed. Try not to make a mistake here. So this looks like 6 minus 6, and the rest looks like 2 2's 4 minus 16 and minus 8. The numbers are big, but that doesn't change the concept. Minus 16 and 8 and minus 8, that's minus 24. So let's summarize. I think my y value is correct. I'll have to double check it. 4 4 16, that's minus 16. 2 cubed is 8, minus in front of that. Yeah. Okay, so if we were to summarize what I have for the tangent, I have the gradient of the tangent being minus 31, and the coordinates of the point being 2 minus 24. For the normal, I have the gradient of the normal being equal to 1 upon 31, and it's the same point the normal passes through, 2 and minus 24. At least some work for you guys to do here, because you're gonna crunch the big numbers. Yikes. I'm not there. So I will invoke the point slope form of a line, which is, oh man, what's going on? Y minus y1 is m into x minus x1. In this case, it will be m sub t, because I'm finding the equation of the tangent. So therefore, y minus a minus 24, that's y plus 24, is equal to minus 31 into x minus 2. Y plus 24 is equal to minus 31x, and this looks like a plus 62. Throwing everything over on the left, you get 31x plus y, and I don't know what's 24 minus 62. I can't subtract to save my life. For real? Minus 38. I have to use the calculator. That's the equation of the tangent. I think y'all can double check my algebra there, and my little arithmetic as well. Same, in a similar manner on this side, we'll have y minus y1 is equal to m sub n. You go into the normal into x minus x1. Y minus a minus 24, which is plus 24, is equal to 1 over 31 into x minus 2. And y'all can finish this up. Multiply through by 31 and get your big numbers and whatever else. Alright, I'm gonna leave this here. And that's the concept, basically, to find the equation of a tangent and a normal to occur at a given point. I'll give two problems here. Now remember, they don't have to give you the point directly. So I'm gonna let me see how well you're thinking about these ideas. Here's my worksheet. equation of the tangent and the normal to a curve. We got a couple of nice ones. Number 1. Find the equation of the tangent and normal to the curve. The curve y is equal to 5x squared plus 6x minus 3. Equation of the tangent and normal to that curve at the point where the curve cuts the y-axis. There's only one point where that curve cuts the y-axis. You have to know that when the curve cuts the y-axis, what value x should take on, and so on. All right. Number 2. Now this one, find the equation of the tangent and normal to the curve y is equal to 4 upon root x at the point where x is equal to at the point where x is equal to 9. Yeah. And one more. This one is rather lengthy. Find the equation of the tangent and normal to the curve y is equal to x squared plus 1 times x plus 3 at each point where the curve cuts the x-axis. I have a feeling in this last one you'll end up with 6 different equations, 3 tangents, 3 normals. There are 3 points where this curve cuts the x-axis. All right, that's it for this tutorial. I'll probably wait until next week because you might have your hands full here. We have 3 tutorials now so far. One with the basic concepts of calculus in general, and then how to differentiate a polynomial function. The second concept was how to use the gradient function to find the gradient of a curve at a point, and hence the gradient of a tangent to the curve at that point. And then this third tutorial dealing with using the gradient function or using differentiation to find the equation of a tangent and the normal to a curve at a given point or at several points. All right, that's it.